Welcome again. So in this video we'll be proceeding with the optimized approach of the set matrix 0. uh, Before that, let's discuss the time complexity and space complexity of the basic approach we did in the last video. So basically it was here we are doing m iteration, and then let's say m of 0 dot length is n, so m into n, so it's O of 1, O of 1 and O of 1, so it's basically O of m into n or O of n square. And here also it's m, and if it is n, so n, this will take O of 1, this will take of course m, and this will take n, so m plus n, so m plus n into m, so basically it's kind of n cube, so it's O of n cube. Time complexity is O of n cube. Seeing the space complexity, it's showing n square, m into n, and it's just 1 and there's nothing else. So space complexity is n square and time complexity is n cube. Now let's move on to whether we can do it in n square time complexity. So for the next approach, what we think is, like, suppose if we want to make this element 0 where the cursor is pointing, this is 1, so how do we know if this has to be 0 or not? This has to be 0 if you can see 0 here, like 0 here, like if you can see 0 in this place, in this row, the row in which this 1 is present, if you see 0 in the row, in any of the column of the row, so then it will be 0. So that's the basic thing you need to see, like if 0 came in either of the column of this row, then this one will become 0, or if this one will become 0 if and only if either of the column of this row will 0, or either of this column, either of the row of this column is 0. So basically, how do I show you? Let's pause. So yeah, you can see here what I was saying. I was talking about this one only, right? So if you see 0 in either of these rows, what is where it is a row only, either of the column of these rows or either of the row of these column, this one will become 0. So what we will first do is, whenever we'll be traversing all the way all the elements of this matrix, and whenever we found the 0, we will mark first of all we will take row and column matrices, row and column arrays. So basically this is column and here it is row. So whenever we found and after traversing all the way all the elements of this matrix, whenever we found 0, we will mark the row, the index, this is 1 comma 1, so row of 1 will be 0 and here also column of 1 will be 0. Column 1 will be either 1, or you can say something, because it's already initially filled with a 0, so you can mark it with 1. You should mark it with 1, because you cannot mark it with 0 because it is already 0 and you cannot differentiate it afterwards. So here it will be 1. Here I have taken -1, or you can take it 1. So that's it. You marked it 1, and here also you marked it 1. So what this symbolizer means, it means that this one means that the row of this column is entirely filled, should be filled with 0. And here also it's saying that column of this row entirely filled, which entirely should be filled with 0. That's what it's like. So let's proceed with the code and you'll understand more clearly there, I guess. So first of all, let's generate row array. So yeah, m dot length size, row will be of m dot length size, and int m of 0 dot length. Now, as we said earlier, we'll be traversing m dot length I plus plus. Let's just change to m, and again we will 0 m of 0 dot length j plus plus. Now if we get m of I of j equals to 0, then we will r of I of 0 of of 0, basically it is r of I, right? R of I. So here I actually put the wrong notation. R of I should be 1, and C of j should be 1. Now we will traverse m dot length I plus plus for int j equals to 0 0 dot length j plus plus. So if we got r of I equals to 1, or C of j equals to 1, then we will mark m of ij equals to 0, and that's it. So let's just, so it is accepted. Now yes, so that's the second optimized approach. Thanks.